Welcome, my dear students, to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 3, Normal Distribution, brought to you by Vitan Sir. In my previous tutorial, I completed illustrations up to number 17. You can find the link of that video on the top right corner of your screen. Now, each and every illustrations remaining, that is illustrations from 18 to 22, all of them are small questions. Okay, they are about answering the questions using typical values. Now, if you remember, in my earlier video I explained the characteristics or the properties of the normal distribution and standard normal distribution. If you can't find it, you can find that link on the top right corner of your screen here. In that video, I have explained some characteristics and some ready-made values of the probabilities and the values of quartile deviation, mean deviation, first quartile, third quartile, and some range values. So just revise those characteristics first and then start with the illustration. So we will go on with the illustration 18 here. The probability density function of a normal variable is as under, which is fx 1 upon 4 root 2 pi e raised to negative 1 upon 32 into bracket x minus 50 whole square, where x is between negative infinity and positive infinity. Now what we have to do is obtain parameters of this distribution and calculate first question probability x is between 52 and 58, and second probability modulus x minus 45 less than equal to 4. Now because actually for calculating any probability we need the values of mu and sigma first, so let's see how we can do this. Here we have the probability density function, so we will compare that probability density function with our original probability density function which I explained in my very first tutorial for the normal distribution, which is 1 upon sigma root 2 pi e raised to negative 1 upon 2 x minus mu upon sigma whole square. Now, if you compare these two probability density functions, you will see some similarities. For example, this is 4 root 2 pi. This is sigma root 2 pi. So naturally 4 and sigma are similar. Naturally this is x minus 50. This is x minus mu. So 50 must be mu. So mu will be 50, sigma will be 4. So this way, by comparing these two functions, we can get our answers for mean and standard deviation. After getting these two values, we can directly start with calculating these values here. We will start with the first one, that is x is between 52 and 58. 52 minus 50 upon 4 less than equal to z, less than equal to 58 minus 50 upon 4. The answer here will be 0.5 less than equal to z, less than equal to 2. So the curve which I am going to draw here is going to be positive 0.5 to positive 2. So this is the area for which we are going to calculate the probability. How we are going to do that? Now from the previous tutorials, if you remember, we take 0 to 2 and then subtract 0 to negative or 0 to 0.5. Now from the previous tutorials, I have the table value of 2 as 4772 and 0.5 as 1915. So I'm not showing the table here because we already have those table values. The difference 2857. So my dear students, the probability that 52 less than x less than 58 is 0.2857. Let's move forward with the second question, which is a bit different for you guys. You might think that it is a different question, and yes, it has a bit of a difference. According to the definition of the modulus, whether it is a positive value or a negative value, the outside value is always positive. That means this 4 could be a positive 4 or a negative 4. So if it's a negative 4, it will be on the left side, and if it is a positive 4, it will be on the right side. That means if I remove the modulus here, according to my modulus theory, I get two options, negative 4 and positive 4, and that means x minus 45 is either between negative 4 or positive 4. So negative 4 less than equal to x minus 45 less than equal to 4. Now if I add 45 in all these three values, so I will add 45 into negative 4, 45 into x minus 45, and 45 into 4. Why am I adding 45 here? Because this x minus 45, I just need x. So to remove negative 45, I will add 45 there. So negative 4 plus 45, negative 45 plus 45, and 4 plus 45. And at the end, you will get 41 less than equal to x less than equal to 49. So from modulus x minus 45 less than equal to 4 to 41 less than equal to x less than equal to 49 is how we move forward. So you guys remember this thing also, that this is how you have to convert these modulus values into our regular ranges. Now we will be converting this into our z score. 41 minus 50 upon 4 less than equal to z less than equal to 49 minus 50 upon 4, which would be negative 2.25 less than equal to z less than equal to negative 0.25. Now naturally this is not a value which we can get without a table. So negative 2.25 and negative 0.25 and the area between these two, this is the highlighted area for which we are going to calculate. So it will be negative 2.25 to 0 and negative 0.25 to 0. For this we will need a table. So starting with 2.25, so this is 2.2, okay, right here, and 2.25 is right here, so 4878. And similarly 0.25, so 0.2 50987. So 0.4878 minus 0.0987, and the difference will be your answer 0.3891. So the probability that x minus 45 modulus less than equal to 4 is 0.3891. So this is a kind of a question where you use your original equation. Moving on towards next illustration, that is illustration 19. In illustration 19, the probability density function of a normal variable is as under. Okay, this is something similar. Fx is constant into e raised to negative 1 upon 2 x minus 25 upon 10 the whole square. Okay, now naturally, if we are going to compare this, we have to estimate three values here, that is third quartile, quartile deviation, and mean deviation. So we will be comparing this equation with our original density function. So forget about this first part, this constant part. From this part only we can calculate mu and sigma. You can see x minus 25, x minus mu, so mu is 25 upon 10 upon sigma, so sigma is 10. We got it directly. Wow, so simple. So mu is 25, sigma is 10. What we need is quartile, third quartile, quartile deviation, mean deviation. Now these are very simple. Start with the third quartile. Okay, now third quartile, if you remember from the characteristic value, third quartile is mu plus 0.675 sigma. Okay, so in the place of mu you write 25 and in the place of sigma you write 10. So just multiply 10 with 0.675 and add it into 25, you get q3 is equal to 31.75. Simple as that. But for this you need to remember the properties well. Quartile deviation is QD. Once again refer to the properties. QD is 2 upon 3 sigma. We already know sigma is 10. So QD is 2 upon 3 into 10 and your answer is 6.67. Okay, similarly mean deviation, again refer to the properties. MD is 4 upon 5 sigma, where 4 upon 5 into 10 will get you 8. So you got third quartile as 31.75, QD as 6.67, and MD as 8. It was that simple. It was really a very simple sum if you would remember the properties well. Keep that in mind. Illustration 20 follows something similar. The extreme quartiles for a normal distribution are 20 and 50 respectively. Now we have to obtain the limits, which includes 95% of the observations of the distribution. Now once again we have to refer to the properties in which refer to the very last property in which we had some 5 or 6 different probability values. In that, refer to that probability value which had 0.95 probability. Okay, 0.95 is practically 95% if you multiply it with 100. So what were the limits for that? Just refer to that and move forward. The extreme quartiles are Q1 and Q3. So the bigger value is Q3, that is 50. Smaller value is Q1, that is 20. Always Q3 will be bigger than Q1. It's a common sense. It's a common sense. Okay. So we need to find limits of middle 95% observations, which are mu plus minus 1.96 sigma according to our properties, which I just told you guys to refer. That means we need mu and sigma. What we need is mu and sigma. Now, how are we going to do that? We know that mean is equal to median is equal to mode, that is third quartile and first quartile average. So 50 plus 20 upon 2, that is 70 upon 2, that is 35. So directly, this is actually the method to calculate median, but we already know that mean, median and mode are equal. So you can calculate the calculate using the method of median and then just call it mean. It is possible. So mu is 35. Next, we know that quartile deviation is 2.3 sigma. Now, why am I using quartile deviation? Just take your brains back to the 11th standard. Remember, what was the formula of quartile deviation? It was Q3 minus Q1 upon 2. Okay, so Q3 is 50, Q1 is 20 upon 2 is equal to 2 upon 3 sigma. Just change the sides. 50 minus 20 is 30 upon 2, and 2, 3, when you change the side of it, it becomes 3 upon 2. So the final answer here is sigma is 22.5. Next, we are supposed to calculate limits of the middle 95% observations, that is mu plus minus 1.96 sigma. So that is mu minus 1.96 sigma and mu plus 1.96 sigma. Just put the values there. 35 minus 1.96 22.5, 35 plus 1.96 22.5. So it will be 35 minus 44.1, 35 plus 44.1. So the limits of 95% of the observations are negative 9.1, 79.1. Just look at the question once again, the answer properly, and once you are satisfied that okay, you got it, move forward with the next question. Illustration 21. For a normal distribution, the first quartile and the mean deviation are 20 and 24 respectively. So the first quartile Q1 is 20 and MD mean deviation is 24. We have to estimate mode. Okay, let's see here how we can do this. MD is 24, Q1 is 20, and to calculate mode we can use median or mean, but for that we need SD first. Okay, mode can be calculated using the methods of calculating mean or median, but for either we need the value of standard deviation first. So let's see what we can do here. MD we already have, which is 24. So in the place of MD we will just write 24 and change the side of 4 upon 5. So it will become 5 upon 4, and thus your answer will be 30. Okay, so 24 into 5 upon 4 will be 6 5s are 30. So the value of your sigma here is 30. Next, use the quartile deviation method. Why? You will need the third quartile for the purpose of calculating mean here. So quartile deviation is Q3 minus Q1 upon 2 is equal to 2 upon 3 into 30. So naturally you will get your answer as 20, and when you change the side of 2 it becomes Q3 minus 20 is equal to 40, and when negative 20 goes to the opposite side it becomes plus 20. So Q3 is 60 in this equation. You have got Q1, you have got Q3. You can just calculate, you know, median method, and that would be equal to mode. So Q3 plus Q1 upon 2, that is 60 plus 20 upon 2, which is 80 upon 2, which is 40. So the value of your mode here is 40. I hope you guys got it properly. Just have a look at it again, and in case of any doubts, again have a look at it, and still if you are not clear, then contact me. You can always do that. Let's move forward with the last illustration of this tutorial and even this chapter. Last illustration of the tutorial and the chapter, illustration 22. The number of vehicles arriving at a toll station during busy hours of a national highway follows normal distribution with mean mu and SD sigma. Oh dear, you don't have these values. The number of vehicles during two different time periods are 88 and 64, and if the z-score values of these are 0.8 and negative 0.4 respectively, then find mean and SD. Oh god, we have to calculate mean and SD. Knew it. But this time it is a bit easier. Do you know the reason? In the previous sum, in the question number 17 which we calculated, in that question we had to find out z-score values on our own. That means the x values were given, the probabilities were given, and we used those probabilities to calculate z-score values. In this question, z-score values are already there. So we just need to create two equations, use the elimination method, and find out mu and sigma. Let's do it. Starting with here, when x is 88, the z-score value is 0.8. That means z-score is x minus mu upon sigma. Now this is something which you already know. So we can put these values there. Z-score is 0.8, x is 88 minus mu upon sigma. So let's just change the sides of this sigma in mu. It will become mu plus 0.8 sigma is equal to 88. Okay, so that's equation 1. Next, when x is 64, its z-score value is negative 0.4 and z-score is x minus mu upon sigma. So just put them. Negative 0.4 is equal to 64 minus mu upon sigma. So when you change the sides of sigma in mu to the opposite, it becomes mu minus 0.4 sigma, because 0.4 is negative. So mu minus 0.4 sigma is equal to 64. Now this will be your equation 2. So we are going to eliminate equation 2 from equation 1. So first we will write equation 1 here, then we will subtract equation 2. So all the signs of this equation 2 here, this mu here will be negative mu, negative 0.4 sigma will be positive 0.4 sigma, and 64 positive will become 64 negative. Okay, so after underlining them, we get cancelled mu, 0.8 plus 0.4, that is 1.2 sigma. 88 minus 64 is 24. So 1.2 sigma is 24. So when we take 1.2 in the division here, we get sigma as 24 upon 1.2, that is 20. So sigma is taken as 20. Now take this value and put it in the first equation. If you want, you can put it in the second equation, but I am putting it in the first. So in the place of sigma, it is 20. Multiply them, you get 16. Change the side of 16, you get mu is equal to 72. So in the end, sigma is 20 and mu is 72. So my dear students, with this I end my today's tutorial here. It was a bit shorter than my previous tutorials, but then again the questions were also smaller. In this this particular tutorial, the 5 last illustrations use your equation, probability density functions, and a lot of properties. So you need to keep those things in mind, the small things in mind. Most of all these questions had a weightage of 2 or 3, 2 marks at the most. Okay, because they were kind of short questions, and they must this kind of questions can also be asked for 1 mark or in MCQs. So you have to be mentally prepared for them. So study the properties very carefully and study all these illustrations from 1 to 22. In my next tutorials, I will be discussing selected questions from the final exercise of this chapter, as there are no exercises, the separate 3.1, 3.2 kind of exercises here. So I will explain you guys, for the rarest of the rare occasions, the final exercise sums. So till then, see you. Thank you for watching. Like my channel, like this video, and subscribe if you want. I will see you next time. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics, and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.